And good morning and welcome everybody. Today I'll be speaking again about AI agents, and this time I'll be focusing on the ADK, the Agent Development Kit, a fairly recent agent framework which has been released by Google a few months ago. Initially in Python, but there's a Java version that was released as well. And I'm also, I'm a committer on Longchain4j, but also a committer on this ADK for Java framework. So my name is Guillaume Laforge, I'm a developer advocate for Google Cloud, and I'm happy to tell you all about ADK. So what are AI agents? By now, maybe halfway, at least halfway through DevOps, you might have heard a few different definitions, but basically AI agents are autonomous systems that can perceive and act upon their environment. We're using LLMs. LLMs are able to do function calling and use tools, so we can allow them to interact with their environment. And those agents are reasoning, they are planning. Maybe a complex task has to be split into smaller subtasks. And what else? And you have to remember that it's non-deterministic because you're never sure that the agent with the same input will do the same thing. So that's pretty challenging. And I like to represent this as an equation. So an AI agent, you have the LLM, which is the brain of the agent. You've got the memory, because the conversation, since LLMs are stateless, you have to handle the conversation and send that over and over to the LLM, but that's the job of the framework to take care of that. There's the planning phase, how the agent will figure out how to split into potentially smaller tasks, the big goal it has to achieve, and then tool use to interact with the external world, called external APIs, services, etc. And somehow you've got a big for loop over that, an interaction with the user or different sub-agents collaborating together towards the goal. So ADK, it's open source. The Python version was released at Google Cloud Next in, I think that was April, and in May or so of last May, so that's still fairly recent. There's the Java version that was released, and there are other languages that are coming. Let's move on. So let's get started. So I have too many slides, like 50 slides and 15 demos. So let's see how what I can show you today. To get started, it's easy. As with any Java framework or library, you add the dependency to your pom.xml or Gradle build file. That's the main dependency, but you also have this one, which provides a developer UI to interact with your agents directly without you having to provide a UI. But that's mostly for debugging purpose, development purpose, etc. And creating your first agent, so you've got this LLM agent builder that you can use, and you have to define a few things. You have to define the model you want to use. So since it's from Google, there's a direct integration with Gemini. There's also a built-in integration with Anthropic Claude, and we'll see later on that you can actually, I build an integration with Longchain4j so that I could use all the languages, all the LLMs supported by Longchain4j inside ADK. So there's a cross pollination in a way between frameworks. So a model, you have to give it a name and a description. But the other important thing to give as well, it's instructions, because that's what's going to give the agent a goal to achieve, and a personality, etc. And also constraints like how it should use this tool, when, and that kind of things. And so this is the dev UI. So I'll show you a first example, which is here. So I have a little agent here that's a science teacher, a friendly science teacher that explains concepts in a simple way and concise way to teenagers. Okay, so I've already started. So the dev UI is a Spring Boot application. I've already done a few requests, but for now we don't need to look at the console. So this is the dev UI, which helps you develop and debug, etc., your agents. And I have all my agents here. So you can see things like the events. It's an event-driven kind of run loop. state, etc. And here you can enable or not streaming. So for example, I'd like to know what is Proton. And then it's going to show you the answer, hopefully not too, in a simple way, somewhat simple way. But I'd like to show you another cool thing, which is quite unique to this framework. So I built another science teacher, the same one, but I configured a special model that we released a few weeks ago, which is a flavor of Gemini that's targeted for native audio kind of dialogues. So I configured, so I added some extra configuration to show you that you can use different languages and even across, so there's English US, English other countries like UK, etc. And you can choose among 20 different voices or something like that, I forget. So let's see, I'm going to ask another question, but this time using the microphone. What is a quark?
A quark is a fundamental particle that makes up protons and neutrons. It's one of the smallest particles we know of, and it's a building block of matter.
Thank you. So I'll stop there. So I'll kill it there because it's going to continue the conversation. I don't want to continue speaking about quarks and protons. So it's a nice little thing if you want to build voice interfaces. So it's quite funny. If you want to use and launch the web UI yourself from code, you can do that with this ADK web server start method, and you pass directly the agent definition. Or there's also a Maven plugin, so you have to implement some kind of loader class that lists all the agents that you want to load. But so I don't show it here, but you can also launch it from your build if you want. All right, so let's have a look now at the tools. There are 5 different kind of tools. There are function tools and also long-running function tools. So these tools are pointers, let's say, to methods on your own classes with your own code, basically. So the agent can use and invoke your own code. You've got also a few built-in tools, for example, Google Search, and we'll see that in a moment. And you can also delegate. You can transform, in a way, an agent into a tool. So instead of having the tool collaborate, somehow you transform an agent as a tool, as if it were just an MCP server or something. So you can compose things in a neat way. And of course, there's MCP handling. So let me show you first the function tool. So maybe I'll show the code directly. Whoops. The code. Let's start with the stock ticker. So I have a stock exchange expert. I'm going to ask, what's the stock price of some company? But notice here that I've added a tool, a function tool, and I define this lookup stock ticker method here in the same class. And I'm annotating that method with an @schema annotation to tell the LLM, oh, well, this is the name of the tool, this is what you can use it for. And same thing, I also have a schema annotation to annotate the parameters that are passed to the to the tool. So here I'm giving a random stock price, but for Devoxx I'm saying, no, I don't know, it's not it's not yet on the stock exchange, I guess. So let's see that in action. Stock ticker. And I'll show you something that I like in the UI about this. I'll show you the events there. OK, so what's the stock price? I'll start with Devoxx. Of Devoxx. It's using tools. So you see in the UI, so you can even click there, and you can see what was sent, the function call, and the function response. So it got a response saying error, impossible to look up the stock price of Devoxx. But now let's what's the stock price of, let's say, Google? Let's see if I'm rich or not. or richer, maybe. Stock, I'm not rich. I'm sorry. So again, same thing, but you see that this time it returned say just a random value. I didn't plug the real finance service behind, but that's the idea. And notice that you have to return a map. So maybe it's a bit of a constraint in a way rather than like directly rich object. Oops, don't want to type anything there. Because usually the good practice is to return like a map with a key and the good result or some error or some message if something went wrong. So that's the usual practice there. So the annotations, yes, I've already said that. So there are built-in tools. Built-in tools like Google search. So if you know that LLMs have a cutoff date, they've been trained on data that's up to date as of, let's say, January of this year or something like that. So for example, I'll show you that in an example, actually, in a demo. That will be more fun. So if you know a little bit about politics in France, so for example, if I ask an LLM, or maybe I should ask, well, I don't have an example like this. So if I asked an LLM without the Google search tool, who is the Prime Minister of France, it would struggle. But let's see, I'm adding Google search, okay? Who is the Prime Minister of France? Let's see what it says. I'm curious. But normally it should say, okay, as of October 9th, Sébastien Lecornu is the acting Prime Minister following the resignation on October 6th. So it's correct. And also you can see that the UI also shows the search queries it used, and you can also double check what, so maybe usually I see, I think there's a place where you can see the actual, or maybe it's not showing up there, but you can see things like the URLs, let's say markers or the position in the text of the response that correspond to search results that it found in Google search. Well, it's not visible there in the UI, but if you really want to allow users to say or to view where or to ground the answer directly on the search results, you could add some marker annotations or citations marks to say, okay, this is coming from this search results from Google. So this is interesting for grounding the responses of your agents with the latest information from Google. I have other examples. So there's a Python code executor. So for things like, so this is this one. For example, right, Fibonacci function, and tell me what is fib of like 150. And it's able to, so for tasks that are more like logic tasks and problems like, I don't know, things that require programming rather than, because we know that LLMs are not good at math and logical problems. If something can be programmed, so it's possible to ask the agent to create code and run the code to be able to give the answer to the user. So there are some cases where it's pretty useful. And you see, is it the correct answer? I don't know, hopefully. But I've run that example with 150, and it seems to be always the same result. So hopefully that's really the execution of that code. And maybe a little bonus point. So there's not yet built-in tool for Google Maps. It's already there in the Python version, but it's not there yet in the latest release of ADK for Java. But I built one. So for example, and I'm going to show you the code. So latest news, yeah, Python. Yeah, I didn't show you the code, but basically for the news search, I just added the Google search. I gave it the date just in case, so it knows when things are past or more recent. And for the built-in code execution, it's very simple. You just pass new built-in code execution, and it's able to write code. So there's not yet a Google Maps integration, but I created one. So I actually hacked this. I think there's probably a better way to do it, but since there are two flavors of the Gemini API, the one from Google Cloud and Vertex AI, and the one from DeepMind, let's say, for tinkers, etc. But this feature is only available for cloud customers. And so I'm connecting to Gemini this time with a special Google Cloud project. And I created my own model, basically, which extends rather the base Gemini model. But I wanted to configure the way, because it's possible to ask Gemini directly and configure extra things and tools. And here I configured Google Maps and said, okay, this is Antwerp coordinates. So if I run that agent, local guide, and I ask what are, so I've put the marker near the central station in Antwerp. What are good restaurants in, well, no, I won't say in Antwerp, around. I'll say around. And it should give me, maybe I can increase a little bit, the font size. It should tell me, yeah, there's these restaurants. So do you recognize some? Yeah, which one? I think I've been to, or I've been told about this one, but I don't know. So you, for those who are locals, you recognize some of the restaurants around? Yeah, okay, good. So that worked. All right, so that's it for built-in tools. Yeah, agent as tools. So we can compose agents in different ways. We'll see that in a short moment. But you can delegate some tasks to another agent, and you actually wrap it as a tool. So what's interesting is that normally when you compose agents together, they share the same context, the same state, etc. But if you want an agent to be used in its own context without knowing about the rest of the conversation, etc., and the state, you can actually wrap it into inside a function tool and give that as a tool to the agent. So I don't think I built an example for that one. So I'll switch to the next stuff. So it's a way to like not containerize, but somehow shield one agent to just focus on a small task without knowing about the rest of the conversation. Just like function tools, you can also define long-running function tools, which are functions, just like the normal function tool, you annotate a Java method, etc. But this time, instead of running a result directly, you actually return some kind of payload that is a status. Like, okay, so let's say, what kind of long-running tool? Maybe I want to I don't know, launch the dishwasher, whatever. Then you're going to start the dishwasher, but you're not going to say, yeah, let's wait an hour for the dishwasher to finish before replying to the agent. So instead you say, well, the dishwasher was started. And there's an event loop, so potentially at some point, once the dishwasher finishes washing the dishes, it's going to reply with an event that, hey, by the way, I finished this tool execution. The other interesting use case for that tool is for implementing human in the loop. That is, if you need a user's confirmation or a request for extra input parameters, etc., you can use long-running function tools for that purpose. Let's have a look at MCP servers. So, you know, these days it's quite trendy to talk about MCP, Model Context Protocol. So it's a way to standardize how we give access to APIs, services, etc. for LLMs. And there are different modes. You have local servers, STDIO, we call them, that run with inputs, system in, system out. And there are HTTP MCP servers that work either with server-sent events, but it's now deprecated, and the new replacement is with streamable HTTP. And actually, when I so it's a recent. So it was supporting server-sent events, but when I was preparing this presentation and the demos, I noticed that there was a bug in the streamable HTTP support. So it doesn't work well, but it should be fixed hopefully when we release the next version. So currently, only server-sent events work. So it's this is the way you configure things. So you define the parameters, the connection to your server, and then you request the tools, the list of tools from that server, and then you pass the tools. So I have an example as well here, my Moon expert. So I built an MCP server with Quarkus using server-sent events, and then I pass the current date, because I want to know the moon phases, and I pass depending on the date, of course, and I pass the tool here directly. So let's have a look. The moon, where is the moon? All right, what is the current phase of the moon? And we should see some function calling going on. And you can see, so there was this function call and this answer, and indeed the MCP server returned. This is the waning gibbous phase. So that's MCP. Now let's talk about multi-agent. Here we only had single agents, but you can create systems with multiple agents collaborating together. So something that's pretty common with LLMs is hallucinations, and one way to reduce hallucinations is also by decomposing things into smaller tasks that LLMs are more capable of solving. So instead of having a huge prompt, you can decompose things and, okay, this task is more specialized. Let's use a sub-agent, and we can combine them together. So there are different patterns, we'll see. But basically how it works in ADK is that it's a hierarchy of agents that you are building. You know, there are frameworks, for example, LangGraph, LangGraph4j, and Cook, who are frameworks which are graph-oriented. There are different patterns to make agents collaborate together. But here it's a kind of hierarchy of agents. So let's talk about sub-agents. So that's where you can combine agents and give them autonomy, and the LLM figures out which sub-agent to invoke depending on the use case. For example, let's say you have some kind of support agent. Maybe you're going to have a sub-agent that focuses on, hey, what's the status of my order? But maybe you'll have another agent that's going to answer questions about, yeah, I have a problem with my product, I don't know how to switch it on, etc. So it can delegate to the right agent. So it's a way to give enough autonomy to a system of agents. And I must have an example there as well. Sub-agents, is it? No, yeah, this one, the content companion, and I can show you the code before. Yeah, that's this one. So I have different agents here. I actually have a search. So the idea of this agent is to search some content on the internet, and then there's another agent whose job is to help you create tweets to talk about what you found via a search. So I have actually a search agent that is a tool here of this agent that's going to elaborate the results of the search from the tool agent. And I have another agent here, which is the social media agent, which crafts social media posts, maybe using emojis, etc. And then I have this supervisor kind of agents, and I give it 2 sub-agents. Okay, so your role is to help bloggers, influencers, etc. Don't search yourself. Use the topic search agent to do the research, and then use this, or potentially use the social media agent, but to tweet, etc. But potentially, when you interact with that agent, maybe you're just interested you're just interested in searching, or you're just interested in posting something and crafting some message. So, for example, maybe I want to search about I don't know. The latest Gemini models, for example. So it's going to transfer the control to the search agent, and you can see here Yeah. So you see, it's going too fast. You can see here like the Google search results that are synthesized and that are given here. So is it new? Oh, it's actually old news. Usually it tells me about the latest because we released. Oh yeah, no, there's October and October. Yeah, for example, just yesterday or the day before. On Tuesday evening, we released Gemini 2.5 computer use, which allows Gemini to control your, for example, your web browser and potentially later on mobile phones, etc., to act and do research for you, etc., to automate the use of software like a web browser. So it's indeed a recent search results because it's like from 2 days ago. So I just interacted with that agent, but now maybe I want to do a social post, maybe I want to search about and search for another topic. But here maybe, okay, let's craft a tweet about the Gemini 2.5 computer use model. And let's see what it says. So it really depends. So it transfers to the other agent this time. And it says, yeah, get ready for a new era. Well, it's super, well, it's not necessarily the way you write my tweets, but not my style. Yeah, the computer use model uses Gemini's visual intelligence to power agents, etc., to interact with user interfaces. And yeah, coming October 7. So you delegate, you give a higher level of agency, but here it's really driven by the user's request. But it gives agency to the agents to figure out which sub-agent can handle a particular task. Sub-agents, then you have, no, yeah, I explained sub-agents, so I'll skip that one. Then you have workflow kind of patterns. So workflow agents, there are different agents. There's sequential agents to do things in a sequence because you always know that you want to do A before B and then C. You have parallel agents because there are things that are unrelated. So maybe you want to launch some searches on different things at the same time. You can use that. And there are loop agents to, especially for refinement, improvement, feedback loops. So let's have a look at sequential agents. So instead of LLM agent.builder, you say sequential agent.builder. And just like we defined sub-agents earlier, that's the same thing. You have to pass the it's actually sub-agents, but that are organized sequentially, basically. So you use the same method, sub-agents, to say, okay, let's say here it's a blog post workflow. So you search for a topic, you prepare the content, and you draft the final post. I have probably an example. I forget what it was. Yeah, a trip planner. So for example, I'd like an adventurous trip in Antwerp for 3 days. Is there something adventurous to do in Antwerp? You may be surprised, actually. And this one, so I have to give it enough information, like the type of trips, where, and the duration of the trip. And you'll see a sequence of things, of invocations. So the first one, again, is doing some search. So for example, explore the underground waterways of Antwerp. Did you know about this? Or discover, yeah, I don't know, axe throwing? Yeah, it's adventurous, right? You're risking your life. And then, so the first one started, well, it's oh yeah, actually I can click. It started with the destination researcher. Then I have another event here. It continued with the itinerary creator. So it should be seen here. Okay, Antwerp, adventurous. So in the morning you do this, in the afternoon you do that. And I think usually there are 3 events, but it seems that, so the last part usually in that demo is about dinners and so on, but it seems it already included this information. So yeah, I have some cool adventures in Antwerp. And yeah, you can see like the sub-agents were defined here. No, that's, sorry, that's this one. I didn't show the right one. So the destination researcher, itinerary researcher, restaurant suggester, and I said, okay, this is a sequence of these 3 agents that should collaborate together. So sequential, parallel, so same thing, but instead of sequential, you say parallel. So it's going to run things in parallel. I must have another example with, the company detective. So I can ask, I'm trying to profile the Google company. And it's going to do 3. See, this one is actually just searching. It's using Google search each time, but I have a sub-agent that's going to tell me about the mission, the headquarters, the CEO of the company. I have another agent to find the latest news about the company, and the last sub-agent is a financial analyst that brings lots of figures, etc., about the company. And again, I'm making them work together. Oh, actually, I have another one, because I actually put them in a sequence. So I have a sequence of this parallel search, and then an agent that compiles all the results from the previous agent. And notice here this notation that the agents, for example, the financial agent, put the results of its synthesis in this state. There's a global state that is shared, and put the results of your research, etc., in the financials variable state, in the state. And then I can reference that state from the final one. So it's really sequence of parallel sub-agents and a final task to be achieved. And it should give you some results. Well, I won't go into the details, but that's a fairly complete report, thorough report. So parallel loop. So I didn't find a good one for loop because I wanted to do a coding agent that improves the code. And so same pattern, loop agent instead of sequential or parallel, and the list of sub-agents. And I implemented, I implemented one, it's here. So I implemented one to say, okay, I want a sub-agent that generates code, okay? And I have a code reviewer agent whose job is to review the code that was generated and give some feedback. Is it good code? Does it, are the conventions, coding convention respected, etc.? And either it says, okay, it's cool, everything's good, so I call an exit loop tool to exit that loop, or if you have some feedback, well, give the feedback, basically. And I define that tool to exit that loop. There are other ways. We'll mention callback later on, so you can exit from the improvement loop with the callback to say, depending on what was the output, I can see that it's finished, so let's stop the loop. Maybe I'll skip this one because it's just like the Fibonacci example, and the problem is that it does just one loop and it never finds flaws in what was generated. So maybe I should combine different models, maybe a model that's not as good as coding, and then the other one would review and suggest improvements. But all right, loops. So they are particularly interesting for refinement kind of loops, for some kind of feedback loop kind of patterns and situations. So how ADK works? It's really an event loop. So we are waiting for initially a user message, then we invoke the agent, and the agent decides whether it needs to call a tool, to delegate and transfer to another agent. And if you want to integrate an agent into your Java application, you can use the runner class. So let's have a look at what it looks like. There are different things you have to set up. Session management, because each user is in its own session, so you don't want to have messages for one user go to another user, so there's a notion of session. And inside that session, there's a session state, so that's like the big map I mentioned earlier for sharing, for example, the result of one sub-agent with another, etc. And any other information that you would like to save in the state. And in particular, we'll talk a tiny bit about callbacks. callbacks can be executed at the end of an execution of a tool, of an agent, etc., to modify or look up what's in the state. So it's not necessarily directly the LLM looking at things, but it can be via code that you modify the state. So basically how it works, you define, so here I'm just using the in-memory versions, but there are also a session service that works on Google Cloud, or you can implement your own if you want to persist session information in a database. You could also write your own, for example. So it's not tied to Google Cloud. You can use ADK anywhere you want with any potentially with any model as well. So you define the memory, session service. You create the session. Your agent, your app, your agent is an application. So you have to define the name of this application. Usually that's the same name as the top-level agent. A user ID to identify a particular user. I forget what this one is about, and the ID of the session. And then you have this runner. So you pass the different things. There are some other services that you can pass. For example, there's what is it called? The memory bank, if you want to have long-term memory, etc. So there are other services that you can pass. And then you run this method, run async, and you've got a flowable, so it's RX Java 3 here. So you've got a flow of events that come back. And you react, the LLM reacts to those events. Well, I just explained that in one of the examples. You remember when there was that was for the company profiler, where there were curly braces, and I was saying that you can refer to the output of another agent, and that's how you can refer that in the instructions of the following agent. And to manipulate the state, it's just like a map. So put name Alex, for example, and then in the instruction you would say your name is Alex because you found, well, the LLM found the name information from directly from the state. There are another kind of state, I would say. It's artifacts. So for example, when you have files, so models like Gemini are multimodal. They understand pictures, videos, audio, etc. So you can also reference, for example, here so far I only entered text, or I entered voice as well. But you can also use maybe send an image, and you want to do something with that image. Or maybe actually I'm going to use this. I wasn't sure if I would be showing this example, but I did. That was a bonus example, but I'll show it now. No, I don't want to show it there. I want to show it from the terminal because the images won't be visible in the dev UI, so I'm going to do it there. Who has heard about the Nano Banana model from Google? Yeah, a few. Okay. I was hoping even more. So it's a version of Gemini that's able to generate images and edit images. And I have, where is it? I have an original image of me, okay? And I'm going to edit that image with an agent. And I actually have to run it from the command line with my own runner at the bottom. So here that's for loading the image. And I have my own runner here that use the runner loop I mentioned because I want to pass the image as an argument directly to my agent. So let me run it, or maybe I should say a few words. Let me run it. That's going to be more fun. All right. So so I don't know where there's this little bulb. Add a mustache to this. What's going on? I know why. Let me stop that because I need to run the. Here the class, because let me see if I have put the I need to pass the image program argument original.png. Apply, save. Okay, so I need to pass the image. Okay, loaded the image, add a mustache to the person in that picture. Okay. And so it loaded, so this is for debugging purpose, but it loaded the image and it found, so data, so this is a table, an array of bytes. And let's see if it's able to add a mustache. So this is in a terminal, so I created some pixelated rendering in the terminal, but I can show you the output. So better with a mustache or not? I don't know. Let's give him long pink hair and 70s vibe. Okay, let's see. Sometimes it gives some interesting results. Okay, so yeah, I had fun coding this little thing. I vibe coded it to transform images into, wow, let me see the real one. I need to reload it. Yeah, not bad, right? Okay, that's me. So Nano Banana is really amazing if you want to edit pictures, and it really, you know, it looks like me, right? So this is kind of cool. Yeah, Nano Banana is great for editing images in particular. So it's great at generating images, but also editing them, like you know, like this, adding hair and so on. Okay, so this one is pretty fun. Yeah, so why, I now forget why I was speaking about, yeah, because so I'm using the artifacts. Oh yeah, maybe I should show the code. No, or actually I think I've put it in the state, so I wasn't even using the artifacts, or am I? No, I put, maybe it's not the cleanest way to implement it. I should put it as an artifact and modify the artifact, but here I put the image in the state directly. All right, artifacts. You can also define an input schema and an output schema if you want to ensure that agents return and follow some structure in their responses. So if you want to return real object and then marshal and marshal to real Java objects, that's a way to ensure. So it's not for text, for producing text, but for producing some kind of structured payload by your agents. You can define the schema with a schema builder, and then you pass this extra parameter output schema to say, okay, generate JSON for that response and follow that schema. Callbacks. So you saw a few callbacks already, for example, in the Nano Banana example. There are actually different callbacks. The before agent callback, so before the agent starts the conversation, and after the interaction with the agent. So you implement this, you add this before agent lambda expression, and you can, you know, log stuff, etc. For example, the agent has started. You also have before model callback. So when you interact with that agent, there may be several calls to the LLM. So you can modify actually the input request or modify the response. So for example, if you want to implement guardrails, your own custom guardrails, you can do that by implementing the before method callback to say, hey, wait, there's something that's wrong with that request. I'm going to reply with an automated answer like, I'm sorry, I can't help you with that. And after method callback, maybe you manage to convince the LLM to do something, but you want to check that the output is correct. Then you can also check that with an after model callback. And last one, that's before and after tool callback. So whenever you use a tool, like the Google search tool, or no, the Google search tool, I don't think you can intercept it, but your own custom function tool, etc. You can get the ADK to call this lambda function. And usually the thing is you return a maybe empty from RxJava when you don't want to change things, but you want to just observe or do some side effect kind of action. But if you want to change, for example, the output of the tools, because you notice that something was wrong or for whatever reason, you can give inside that callback, you can change the result of the tool execution. So you're unhappy with the tool execution, bring a default value or something. You can do that with callbacks. So I have a demo, but it's just logging things, so it's not very interesting. I'd like to have time to talk about this. So I built an integration with LangChain4j so that you could use any model that is supported by LangChain4j. And so far, I've been using Gemini. I work for Google, so I like to use Gemini, of course. But I also like to use local models running on my machine. So I have Ollama running with Qwen locally on my machine. And so it's like the science teacher agent of the beginning of the presentation. And here I say, instead of saying model Gemini 2.5 something, I have this new class, new LangChain4j. So it's a kind of a wrapper around the LangChain4j models, the chat models. So here, this part is really just pure LangChain4j. So this is how I would define a chat model for Qwen using Ollama. And instead of passing Gemini, I can say new LangChain4j, pass that Ollama chat model. So I have, again, wrong shortcut. I have Ollama running here locally. So I'm going to say hello to Ollama, just to see that it's indeed live. So this is, you see, it's Ollama, blah, blah, blah. And OK, how can I help you? So let's see, where is it? I think that's the barista example. And I can show you the barista here. No, wrong window. Barista, where's my barista? Coffee, I called it coffee. I don't know why I put different names everywhere. So, well, that's basically what you had on the slide anyway. But, OK. I'm going to make a joke. Am I late? Am I latte? Or am I on time? And let's see if Qwen gets the joke. Wow, super joke. And let's see what it says. So it's going to call Qwen through Ollama through LangChain4j. And I'm a little bit worried because I don't see, oh, maybe it's because this one doesn't support streaming. Let's see. Not all models support streaming, so maybe that's why I don't see the output. So let's restart the session and not, no, whoops. Am I latte or on time? And I just have 3 minutes. I'd better, yeah, now it should be working. Maybe it's because of the token streaming. I'd have to double check why the streaming doesn't work. Or maybe it's because of that model, I don't know. So yeah, blah, blah, blah. So I guess, so latte and on time. Latte and on time. So I'm going to have a latte, I guess. So yeah, Qwen, it's a small model, but it gets jokes. So that's cool. Quickly, the last few things are the new things that happened in the 0.3 release that was released like 3 weeks ago or 4 weeks, well, a few weeks ago. You can define YAML agents, basically, the agent definition using a YAML file. So you can use this just like we coded with a builder, but here you do that in a YAML file. So you've got the name, the instructions, the sub-agents. You can even point at the code of agent that would have been written with Java, and tools and callbacks. And oh yeah, yeah. Well, I won't show. I won't show this one, but just the code I have. So here, I'm just saying I've got this utility function that allows to load an agent from a YAML file, and I have my YAML file somewhere here. So just like more or less a similar example to what we had. OK, so YAML definition files. There's a memory service for long-term memory. So if you want to remember past conversations with your users across different sessions. So there's a load memory tool to load past memories. And there's a memory service. So this one is an in-memory memory service. But, well, that's weird to have the repetition of memory. And you add that service when you create the runner, when you integrate an agent in your Java application. And then at the end of a session or via a callback, you can add the new souvenir of what was exchanged in that conversation, in that session. There's a plugin system that's been added. So for example, so you can implement, I thought I had, yeah. So you can create a plugin in which you will define several callbacks and also extra things. So the usual callbacks plus a few other callbacks before the agent is run. On user message, each time you get a message from the user, on event callback, because it's an event loop, or on model error or on tool error, and you can handle that. So you can define the plugins that are available via a plugin manager, and then also pass the plugin manager to the runner, and it will apply all those callbacks to your agent. So if you want to have well, this one is a logging plugin, so let's say some kind of observability plugin, you could add that to an existing agent. Advanced code execution, if you want, so the one we saw with Python was the built-in code execution, but you can also define a container code execution. So if you have a Docker container, yeah, this is the one. The Docker container executes your code in a sandbox, basically. So that's handy. And there's also one in the cloud if you really want to. And last little thing, it's easy because of the dev UI application. With JBang, you can quickly launch an agent with just a few lines of code by saying, OK, depend on that. And then in just a few lines, it's like a Java script, in a way, to start your agent. So it's a little bonus. So that's about it. You've seen all the features of this framework, how to make the various agents collaborate together, how to do callbacks, how to use tools. And I'd like to finish with those resources. So I have $105 credits. So if you're interested in trying ADK for Java or anything else, like deploying your own MCP server or Cloud Run or that kind of stuff, you can claim some credits. So it's just $5, but with $5 you can already quite a few things, and even create tons of images with Nano Banana, etc. So claim. So you just have to have a Gmail account, and you can create, if you don't have a GCP project, and then you can apply those credits to your account. So is it OK? Those who wanted the credits took a picture. Good. And the code of this of all these little demos. So that's about it. Thanks again for your attention. Thank you. And I'm a tiny bit over time, so I'll take questions here if you want to ask me anything. Thank you.